Hello everybody, I'd like to talk about the correlation and linear regression. This presentation is considered as an introduction because later we will have some new advanced topics regarding the correlation and the linear regression. Let's first start with understanding the concept of the correlation. Correlation is simply a relationship between two variables. For example, regarding the weight and the height, we know that as the height of the human being increases, the weight is increasing too. So we have, in this example, we have something called correlation between the height and the weight of the human being. For example, let's understand the relationship between the training hours and the skills or the performance of trainees. We know that as the number of training increases, the performance of the trainees becomes better. So we have relationship in this case. So this is the correlation concept. Notice that here correlation does not mean causation. We are not talking about the effect of one variable on the other variable. We are talking simply about the relationship between these two variables. In order to understand the correlation concept, we need to understand the direction of the correlation and the strength of the correlation. Before starting any understanding of the correlation, we need to use what's called the scatter plot. And the scatter plot here represent the two variables. We have two variables. One is represented on the x-axis and the other is represented on the y-axis. So we have pairs between these two variables. We plot all these pairs on the coordinates, same like what we have here. We have here two-dimensional coordinate. So this is called the scatter plot. With this methodology, which is the scatter plot, we can simply understand the general information about the relationship between the two variables. For example, we can simply understand that the relationship between these two variables in this diagram is simply we have a positive relationship, which simply means as the x-axis increases, the y-axis also increases. So the scatter plot is simply a two-dimensional chart. Of course, we have a three-dimensional chart for the scatter plot. And this scatter plot shows the relationship between two variables. For any scatter plot, simply we represent the independent variable on the x-axis. Sometimes the independent variable is called explanatory variable. And the other variable, which is the dependent variable, or sometimes called the response variable, it is represented on the y-axis. So this is the way how to represent the two variables in order to understand the scatter plot and to understand the correlation between these two variables. Let's talk about the direction of correlation. As we see here in this figure, simply we can understand that as the value of the independent variable increases, so does the dependent variable. It also increases. So in this case, we say that we have a positive direction between the two variables. So positive correlation simply means that when one value of the two variables increases, the other value also increases. Sometimes we have a scatter plot, same like what we have in this figure. We can understand that as the independent variable increases, the dependent variable decreases, or vice versa. As the independent variable decreases, the dependent variable increases. So in this case, we conclude that we have a negative correlation. So this is called negative correlation. So negative correlation occurs when if one value decreases, the other value increases, or vice versa. Sometimes we can't predict the trend of the scatter plot or the points on the coordinates, same like what we have here. For example, sometimes as the independent variable increases, sometimes the dependent variable, sometimes it increases or sometimes it decreases. So we conclude that we don't have any correlation between these two variables. So we don't have a direction in this relationship. So here we have no relationship, or simply we have no direction for the correlation. And simply the no relationship simply means that we can't have straight line relationship, same like what we have in positive or negative relationship, or sometimes we have in a linear relationship. I'll talk about it in details in the next presentation. Simply the no relationship occurs when one variable changes. It does not influence the other variable. So we don't have any relationship between the two variables in this case. Let's talk about the second concept of the correlation, which is the strength of the correlation. What we have here in the figure, we have simply a positive correlation, simply because as the value of the independent variable increases, so does the dependent variable. So we have a positive correlation. But we can simply see that we can combine all of these points simply in one straight line. So we can simply draw one line that can combine all of these points. So we have in this case what's called the perfect positive correlation, and sometimes called complete positive correlation. In the next presentation, I will talk about how to compute for the correlation between the two variables. In this figure, we have again a positive correlation, but simply the scatter of the points cannot be joined in one straight line, but we can simply draw a line of best fit, and this line can be very close to all of these points. So in this case, we have high positive correlation. In this figure, again, we can conclude that we have a positive correlation. But if you try to combine all of these points in a straight line, of course, we can't do it. And definitely the spaces between the line and the point will be somehow great. So in this case, we have a positive correlation, but we have a low value for this correlation. In this case, because we don't have a direction for the correlation, so we don't have any strength for this correlation between these two variables. In this figure, we see that the direction of the correlation is simply negative. But as you see, we can simply combine all of these points in one straight line. So if we draw a line, there will be no spaces between the points and this line. So in this case, we have what's called the perfect negative correlation, or sometimes it's called complete negative correlation. Same like what we have here, we have a negative correlation, but simply we can't combine all of these points in one straight line. So we have a high negative correlation. This is also negative correlation, but it is considered to be low correlation, simply because if you try to draw the best line that fit all these points, there will be some distances between this point and the straight line drawn. So this is the low negative correlation. Let's understand the concept of the correlation by taking this practical example. We have a company, and this company has recorded the sales of one item along the 12 months, and we have these records. So in this case, we have two variables. The first one is the month, and the second variable are the sales in dollar. So in January, for example, we have a sales of $1,000. In February, we have $1,850, etc. Sometimes we can't have a complete understanding about some records in tables. Instead, it's better to use the scatter plot, same like what we have here. Here we have the scatter plot between the month and the sales for the specific months. So as you see here, we can conclude that we have somehow a high positive correlation between the two variables. For example, in January, the size of the sales is simply 1,000. So this is $1,000, and this is the month which is the January. This is the meaning of the plot. So again, we can simply understand or conclude that we have somehow a strong positive correlation. In order to understand the relationship between two variables, we need to understand what's called the linear regression, or sometimes it's called line of best fit. Line of best fit is same the line drawn in this figure. It is simply try to cover all the points so that the distances between these points and the line is as close to the line. So the purpose of understanding the linear regression, or simply the line of best fit, is just to make an equation. Of course, we have straight line equation, and the purpose of determining this equation is only to predict. So this word summarize the purpose of the linear regression is simply predicting of the value of y, which is the value of the dependent variable, for a given value of x, which is the independent variable. So this is the concept of the line of best fit. In the next presentation, I'll talk about the way how to determine the equation of the line of best fit. For example, if we try to draw the line of best fit for all of these plots, simply we can draw same like this line. So as you see here, if you try to count the number of plots over this line, we have 2 plots, and also we have 2 plots below this line. So this is the line of best fit that can combine all of these points. This is the linear regression regarding the equation. In order to determine the equation of the regression line, we should know 2 values. So the formula for the straight line equation is simply y is equal to m times x plus b. Y here represents the dependent variable, and x here represents the independent variable. So we have here, we should determine the values of 2 constant, which are m and b. M is simply the slope or the gradient of the straight line, and b here represent the intersection between the straight line and the y-axis. For example, these points, which represent the relationship between 2 variables, we can simply draw a line with this formula: y is equal to x plus 1.5. So we can conclude from this equation that the value of the slope or the gradient of the line is simply 1, and the intersection between the line and the y-axis is simply 1.5. Simply if you try to extend this straight line so that it reaches the x-axis, it will intersect in the 1.5 point. Same like what we have here. We extend the linear regression line. So this is the intersection between the y-axis and the straight line. It is 1.5. So again, the purpose of the linear regression is simply to predict a value for the dependent variable for a specific value of the independent variable. Let's try this simple question. Predict the value of the dependent variable for independent variable x equal 9. So the value of the independent variable here, we have 9. Notice that in this diagram, we don't have a value of x equal 9 in the x-axis. So here we are talking about the prediction. So simply we can substitute for x by 9. So y is simply equal 9 plus 1.5. So the predicted value of y is equal to 10.5. That's all about the introduction of the correlation and the linear regression. In the next presentation, I'll talk about the computation of the relationship between these two variables. Thanks a lot. If you like this presentation, please click the like button and don't miss to subscribe in my channel. Thanks and goodbye.